Mars, the red planet, the final frontier. You know, we're headed there one day. And that's what Mike Pence said back in 2019.
Our objective will be to establish a permanent presence on the lunar surface, and from there we will develop the capabilities to journey to the red planet of Mars.
With NASA's goal to eventually send humans to Mars, understanding the atmospheric conditions and weather patterns on the planet has become increasingly relevant. In this episode, we'll delve into the differences and similarities between Earth and Mars's atmospheres, explore the unique weather on Mars, and even discuss the potential use of moon dust in geoengineering. I'm meteorologist Emily Gracie, and you're listening to Off the Radar, a production of the National Weather Desk. On the show, we dig deep into topics about weather, climate, the ocean, space, and much, much more. Our goal is to help you better understand the weather and to love it as much as we do. Atmospheres are so important when it comes to life. It impacts everything, even sound. Listen to this. Here's what ocean waves sound like on Earth. Now let's listen to the same clip, but this is what it would sound like on Mars. Now, Mars doesn't have any oceans. I know this because of today's guest, Dr. Scot Rafkin. Dr. Rafkin is the Assistant Director of Planetary Atmospheres and Surfaces Department at the Southwest Research Institute in Boulder, Colorado. Unlike most atmospheric scientists, like myself, Scot studies atmospheres beyond Earth. Scot has a talent for making complex science concepts understandable for all levels. So whether you're a science enthusiast or simply curious about the red planet, this interview is sure to captivate and inform you. So sit back, relax, and join us as we go off the radar and 133 miles into space with Dr. Scot Rafkin. I want to talk about weather on Mars because it does have weather, correct? So it must have an atmosphere if you're studying it.
Yeah, Mars does have an atmosphere and it does have weather. It has lots of things that would look familiar to us on Earth. There's also lots of things that are literally alien to us and a little bit of stuff in between.
Okay, so let's start with what is the atmosphere made of?
Sure. Yeah. So Mars's atmosphere is made primarily of carbon dioxide. It's got a little bit of nitrogen and a little bit of argon, but mostly carbon dioxide. It also has some interesting trace gases. In particular, it has water vapor. And that's important for cloud formation and things that we are a little bit more familiar with on Earth.
So for those who don't know about Earth's atmosphere, what that is made of, can you tell us about that and how they compare?
Yeah, so Earth, unlike Mars, is mostly nitrogen. It's about 78% nitrogen. And most of the rest is oxygen, which is the result of photosynthesis from plants. And Earth also has lots of other trace gases, water, of course, which is what produces our clouds and precipitation. And we're also most people are familiar with the trace gas carbon dioxide, which of course is important for the greenhouse effect and climate change.
Right. It feels like we're trying to get rid of the carbon dioxide. So it can't be good on Mars either. It's not a place we can hang out because of this.
Yeah. So I think one of the big differences or key differences between Earth and Mars is that Mars's atmosphere is very, very tenuous. It's very thin. So even though it's mostly carbon dioxide, and on Earth we think of that as causing a greenhouse effect and making things warm, and even though Mars's atmosphere is mostly carbon dioxide, overall it's just got very, very low atmospheric pressure. So just to give you an idea, on Earth we sometimes use the units of millibars, and the surface pressure on Earth is 1,000 millibars, give or take. It's a nice round number. On Mars, the surface pressure is about 7. So, it's order 100 times less atmosphere at the surface of Mars than Earth. It's a very thin atmosphere.
So how far up in our atmosphere would we have to go to get to that point?
Yeah, if you go up in our atmosphere to about 100,000 feet, That would be the equivalent of the surface pressure at Mars. And so 100,000 feet, that's, 3 times higher than commercial aircraft fly. It's, 4, almost 5 times higher than Mount Everest. So it's way up there. And that's just to get to the surface pressure of Mars.
So it's beyond ear popping stage.
Oh, yes. Yes.
All right. Well, let's talk about weather on Mars. What do they experience? Do they have hurricanes? Do they have rain?
They don't have hurricanes, as far as we know, and we don't have rain. The temperature on Mars is far, far too cold for any liquid precipitation. But they do have snow, they do have storm systems, kind of like we have on Earth, particularly in our middle latitudes, like we experience in the United States and Europe and Asia. These are storm systems that have low pressure centers and high pressure centers and cold fronts and warm fronts, and sort of those things that we're used to seeing on a weather map. So Mars has those. They're a little bit different in nature, but they exist. There are also, I would say, the enigmatic dust storms on Mars. Most people know about dust storms. And of course, we have dust storms on Earth too, but they're kind of a different beast on Mars compared to Earth. And so Mars has lots of dust storms in various sizes, from small scale ones and even dust devils, all the way up to these storms that cause global impacts and blot out the sun globally on Mars when they get going.
So something that we always think about, well, scientists always think about when it comes to steering weather patterns, is the Coriolis effect. And so I'm curious, first of all, if you can tell people listening what that is and how it plays a role in our weather, and if that's a thing on Mars.
It is. And so the Coriolis effect is the apparent deflection of moving objects through the rotation of the planet. And it manifests itself on Earth by roughly, in the northern hemisphere anyway, is air flowing counterclockwise around low pressure systems, clockwise around high pressure systems. It reverses in the southern hemisphere. But that's in terms of weather, that's an important role of the Coriolis force. And it just so happens that Mars rotates at about the same rate as Earth. So its day is a little bit longer, but it's 24 hours and change, almost 25, but they are pretty close to Earth. And so the Coriolis force is kind of similar too. And so when Mars has low and high pressure systems, which it does, the air flows around those systems on Mars in the same way that they do on Earth.
Cool. Yeah. And they have a northern and a southern hemisphere too?
Yeah, and the same exact thing. So in Mars, you get counterclockwise flow around lows in the northern hemisphere on Mars, and they go clockwise when you get down to the southern hemisphere, just like on Earth.
Yay. Yeah. Cool. Very cool. Okay, so you are monitoring weather on Mars. We have some really great tools here, but we're also existing here. I'm curious how you're monitoring the weather on Mars.
We monitor the weather on Mars in lots of different ways, and in some ways also similar to how we do it on Earth. So to start with, there are orbiters at Mars, and these have cameras. And not just visible cameras, but cameras that operate in the infrared wavelength and the ultraviolet wavelength. This allows us to see different features of Mars's atmosphere, like clouds and dust. And in the infrared, we can also use different kinds of instruments to actually probe the temperature profiles, the dust profiles, and what the water vapor distribution is like. So that gives us some nice global context and global pictures to kind of see how Mars's atmosphere is structured and how it's moving around kind of on the large scale. And then we have, of course, weather stations that are on the ground. These are primarily on rovers, like the Perseverance rover or the Curiosity rover. And they are just very similar to weather stations on Earth. And they tell us what's going on right at the location of the rover, what the temperature is, what the pressure is, and to some degree what the winds are, what the relative humidity is, or what the water content is. So we can look locally and see what the weather is doing at a place on Mars. And we have the orbiters to give us context for how all that fits into the global picture.
Is there anything that's popped up over the last 2 years as you've been studying it that you've been really surprised and intrigued by?
Yeah, I think there's lots of things. Overall, the especially at the surface, when we look at the weather data, it kind of does what we thought it would do. But so one, it's really good to get the actual details and see and just confirm that, right? So that's part of science is, you make predictions and we think we know what's going to happen, and it's going to get the data back to see that we weren't too far off. But there are some things that are interesting. The behavior of dust devils and when and how dust is lifted has been a little bit surprising. Sometimes we think there should be more dust devils and there aren't, or we think there shouldn't be dust devils and there are. And even just the idea of lifting of dust on Mars is kind of an interesting thing because the air is so thin. So, when there's so little air, how does it actually have enough energy and momentum to actually pick this dust up off the ground? We've also seen some really interesting phenomena related to the topography of the places that we landed, which are mostly in these impact craters or impact basins. And so we see very strong daily upslope and downslope flows that are very localized. We have seen things that we believe are what are called like a Bohr wave. And these actually happen on Earth too, but it's a very interesting structure of kind of cold, dense air that moves in underneath some warmer air and produces some strong winds and other interesting features. So lots of dynamics. The Mars atmosphere is very dynamic, and we've seen just some wonderful range of phenomena come out of that data.
So other than eating snowbirds, what else do humans need to know as we're starting to head towards that eventual goal of getting humans on Mars? How do we prepare?
Oh boy, there's so much to be done. I mean, so first of all, you can't just walk around on Mars without appropriate environmental protections, right? You don't want to take your helmet off. Your blood would boil. You'd have no oxygen, right? So one key thing is just, being able to set up these artificial habitats and artificial environments such that we can provide, an atmosphere for us to live and breathe. I think the second thing from an atmospheric standpoint is the dust itself. When there's a lot of dust activity, it impairs your vision, impairs visibility. You can't see very far. So that can be a hazard. And also the dust can get into everything, right? So when that dust gets picked up into the atmosphere, it blows into all the machinery, all the seals around the doors, presumably around the doors and things that you use to keep the Mars atmosphere out and keep your artificial atmosphere in. So there's lots of things to consider about the atmosphere. We also are very unsure about the electrical properties of the atmosphere. So when all this dust is in the air and colliding, is there essentially static electricity that's created? Can that produce small discharges or electrical shocks, which can damage electronics and other things? So lots to consider from an atmospheric standpoint. And of course, there's other things besides the atmosphere to worry about on Mars as well.
So you say electrical discharge. Are you talking about Mars lightning? Could there be Mars lightning?
There could be, and there's been some searches to see if there's any evidence for that. And there really isn't anything conclusive about Mars lightning. So, and again, it should be clear, Mars does not have thunderstorms like we have on Earth. So the primary producer of lightning on Earth, primary producer are thunderstorms and clouds. So they don't have those on Mars, but they do have, very deep and convective, bubbly dust storms and dust activity. And so there is the idea that maybe lightning and electricity can be produced in that manner.
Are you studying weather on other planets at all, or are you mainly sticking with Mars?
No, I do. I study weather on Earth, of course, on Mars, and especially on Saturn's moon Titan.
Interesting. Specific.
Yes.
My son the other day told me about, is it Saturn's hexagon?
Yeah.
Which is that the big storm? I didn't know about that. That's been going on forever though, right?
Yeah. So when you look at Saturn and Saturn and Jupiter, and they have really complex weather systems. When you get up to their polar regions, they have polar vortices, polar vortex that circulates around. A lot of times those take on very interesting structures like hexagons. They split the cloud patterns into form hexagons. So, and there's lots to learn there. Absolutely. Yeah.
Cool. Does learning about weather on other planets help learn about Earth's own processes at all?
It does. There's a two-way exchange of information. Of course, Earth, we know as an atmosphere, we know most about Earth compared to other places. And so we take our knowledge of Earth and we see whether it applies to these other atmospheres. Are the basic atmospheric physics that we think we understand on Earth, can we apply them to Mars? Can we apply them to Titan? Can we apply them to other atmospheres? And if we can, then that is a strong indication that we probably understand the physics pretty well. The reverse also occurs, though, which is sometimes we see things on these other planets that don't occur on Earth or don't regularly occur on Earth. And that gives us an opportunity to understand some new atmospheric processes and kind of ask the same question of, well, do these things happen on Earth and maybe we just don't see them, maybe we need to look for them, or why don't they happen on Earth? So those kind of things. And I'll also say besides the weather, there is the importance of climate. And I make a distinction there, but of course, climate and climate change is a big issue on Earth. And Mars is another atmosphere with a different climate, but we can understand or try to understand what are the processes that are operating on Mars are similar to Earth. And we can validate our climate models and our climate thinking to see whether the assumptions and other things that we make are appropriate.
I could literally ask you questions all day, but I won't. But this is is there any research you're working on right now that you're really excited about?
Yes.
You're excited about all of it.
Yeah,
I know.
exactly. It's a very difficult question because, I've spent my whole career, really my whole life has been about studying the atmosphere. And so I get excited about it. And I would say all the topics interest me, but with respect to Mars, I think there's really a lot of, especially now, interesting work going on about the dynamics and energetics of dust storms and how they form, how they maintain themselves, how the dust that is lifted into these systems actually either help to amplify or diminish the strength of these systems. This is primarily through a radiative forcing, which is that as dust goes up in the atmosphere, it's pretty bright. And so on one hand, it kind of reflects the sunlight out and can, lose the energy can be lost through that reflection. On the other hand, the dust also does absorb sunlight and can warm. And it's also a very strong absorber of infrared radiation, of heat. And so all it has to get factored into how the energy comes in and out of these systems and how they develop. And there's some really interesting work going on right now by a variety of researchers to try and put it all together and see if we can understand why Mars dust storms blow up sometimes into these big monsters and why sometimes they're there and then we look again and they're gone. Where do they go? So what's going on?
Interesting.
Yeah.
I read an article the other day. I didn't fully read it. I read the title of the article the other day, and it was about moon dust to reflect sunlight on Earth or something.
Yeah, there is on Earth, there's this idea of so-called geoengineering, right? Yes. And, the Earth is getting warmer. This is due to primarily to the input of carbon dioxide and other greenhouse gases. This is not a good thing. So one way to stop that is to directly stop putting greenhouse gases into the atmosphere or even remove them. But that's politically and geopolitically very difficult to do. So the other idea is, well, while we try to figure that out, can we use some stopgap measures? And one way is to just make the atmosphere essentially more reflective. And nature does this sometimes with volcanic eruptions. It puts aerosols, primarily sulfate aerosols, high up into the stratosphere. These are very reflective, and the sunlight reflects off and causes a noticeable cooling, a temporary cooling of the atmosphere until those particles come out. So the idea of geoengineering is, well, let's just put the particles up there, minus the volcanic eruptions, but we can just put the particles up there ourselves and see if we can cause this cooling.
Why moon dust though? Don't we have our own dust? Is it made up of something special that's going to do a better job?
I honestly, I
just like
I haven't heard. It's a really good question. I haven't heard about moon dust in particular. I know the primary thing they're thinking about are sulfate particles, and those are pretty easy to make. And there's no doubt that by adding bright particles, whether I suppose it could be moon dust or sulfates or anything else, there's no doubt it would cause an increase in reflection of sunlight. It would almost certainly cause a cooling. The problem is, the worry is the unintended effects, right? And particularly if you're looking at sulfates or other things, there's chemistry that goes on. There's photochemistry. We don't want to cause a disruption in the natural chemical cycle, which could, let's say, impact ozone and other things like that we care about. And so we need to be really cautious and careful about that, because it's the unintended consequences that we worry about, and not all of them could be good.
Always the balance as a scientist, I assume.
Yeah.
Awesome. Scott, that was great. Thank you so much. I think we have a full understanding of Mars weather now, so I really appreciate that.
Sure. My pleasure.
Thank you, Scott, for that fun and informative talk about Mars. Off the Radar is a production of the National Weather Desk. Make sure you're following the show on Apple Podcasts, Spotify, or wherever you listen to your podcasts. New episodes publish every Tuesday. If you know a space enthusiast, please share this episode with them. And feel free to rate and review us on Apple Podcasts and Spotify. Let us know what you think of the show. You can also suggest new topics for us to touch upon in future episodes. Check out our YouTube channel where you can see the video version of this interview. There are links in the description where you can monitor weather on Mars. All you have to do is search the National Weather Desk on YouTube. This podcast is produced, hosted, and edited by me. Special thanks to Eric Newell and Richard Cook for their contribution, and also thanks to NASA for the sound clips at the beginning of this episode. I'm meteorologist Emily Gracie. Make it a great day.